I am Mr. Ish. Good evening to all of you watching this video. Thank you for watching this. We have a video over here on angles and circles, an application style of video looking at two questions as always. The first question is this: going from 4 o'clock to 6 o'clock, how many degrees and radians is that? O'clock. You know, we're looking at 4 and we're going to 6 o'clock. From 4 p.m. to 6 p.m. It doesn't matter. What do you think about when you're looking at a clock? You could very well be thinking about a circle having 360 degrees and 2 pi in terms of radians. If you're going from 4 to 6 and you know clock time is measured in terms of what you see into 12 units, right? 1 through 12 o'clock, that's 12 units. You can take 360 degrees and you can divide that by 12, and that'll very well give you in terms of degrees from each o'clock to the next. 360 divided by 12 is 30. Since we're going 2 o'clocks from 4 to 5 and 5 to 6, we're looking at 30 times 2, and that answer would be 60 degrees in terms of what you see here. Well, we got to present this in the form of radians as well. You know, going from degrees to radians, you multiply by pi over 180. I presented a video on this conversion. You can always check that. 60 times pi divided by 180, cancel these out. You have 6 pi over 18. You can say pi over 3. A good measure of an angle which is 60 degrees is pi over 3, something you should ideally commit to memory so when you see it you know it. This first question has been done. Degrees 60 and radians pi over 3, going from 4 o'clock to 6 o'clock. Alright, second question, last question, interesting question. We have a circle drawn. In that circle we have highlighted two chords or two segments. One segment is AB, the other segment is CD. We know that both of these segments AB are equal to each other. AB chord or segment is equal to CD chord or segment. We have to find this angle X. Nothing here is drawn to scale in terms of angles, but this angle here happens to be 70 degrees. This here happens to be the center of that circle. When you're looking at a center of the circle and you're drawing a line towards the outer edge or the periphery of the circle, each of those lines is reminiscent of a radius. Going from here, this right here must be a radius. Going from here to here, that must be a radius. This right here must be a radius, and this here must be a radius. If you just pluck out one of these triangles and it looks exactly like this, we have this AB side over here, we have 70 degrees here, and I know I have one side here R and one side here R. They're both equal to each other. If they're equal to each other, you know this angle is opposing that side and this angle here is opposing this side right here. If both of these sides are equal, then the angles that oppose them must be equal, and therefore this must be 70 degrees. You know you're looking at an isosceles triangle here. Two equal sides, therefore two equal angles. If this is 70, this is 70, then this right here must be, you know it, 40 degrees, because the sum of the three internal angles of a triangle are 180. 140 minus from 180 will give you that 40. If I know now that this is 40, then I know easily what this right here must be, because I'm looking at what happens to be a straight line, 40, and then therefore this must be 140 to give you a supplementary total of 180 degrees, which is a straight line. Alright, you saw that. This right here is 40 degrees right here. Therefore this must be 140, and all of this together in unison is 180 degrees. So find the angle X, it's 140 degrees, and you would never be wrong with that answer. A good measure to see if your answer is right, all of these angles here should add up to 360. When I'm redrawing everything over here, I see a 40 over here. I see the opposite angle must be 40. This is 70, that's 70, that's 40. This is 70, that's 70, that's 40. Here's a 40, here's a 40, here's 140. Remember, opposite angles are always equal, especially when you're looking at on opposite sides of intersecting angles. If you add all these four angles, 40, 40, 140, 140, you'll get your 360 degrees. And I'm 100% confident that this answer is right. And let's say goodbye with that statement of ours, that assertion. Thank you for watching. Have a nice day.